la famille.
Okay, so, well, I guess, thank you for the introduction. So yes, I did a lot of different things before joining AWS. So that's it. Nothing else to say about that. I'm really here today to talk about AWS. So my name is Julien. I'm a technical evangelist for AWS. I'm based in the Paris office, but I do travel a lot. And actually, it's pretty cool to be in Paris and talk to French people. Most of you are French. I don't know why I'm doing this in English anyway, but okay. It's a fashion thing. So by the way, if at any time during the presentation you want to ask a question, if there's something you don't understand, if my English is broken, if your English is broken, please raise your hand, interrupt me. This is perfectly okay. And of course I'll be around at the end of the presentation. So if you want to ask questions in French afterwards, that's fine too. Okay. So my goal for you, my goal for today is really to make sure that you leave this room with a good understanding of all the crazy stuff I'm going to talk about. So please ask questions. Okay. I changed the title. You know, we have this little game of changing the title. So I figured, okay, let's change it another time. And so that's my title for today. Scale, baby, scale. This is really what we're going to do. So let's get started. So you guys are building web applications, web platforms. You're going to start in your garage, in your basement, in your dad's basement, who knows? And so day one, it's only going to be you, right? Just one user. So day one, user one, new project. You have this nice business idea that you want to grow into a platform. And so it's quite likely that you're going to start with a single EC2 instance, a single virtual machine. And you're going to put everything on it. You're not going to worry so much about scaling because, that's not the point, right? The point is to get to your MVP or your prototype or, whatever you want to call it. So you're just going to put everything on that instance. You're going to put the web application, you're going to put your database, all your tools, etc. Right? You're not worrying so much about the architecture. So it's a single instance with an IP address that's accessible from the internet, hopefully. And hopefully with a domain name, right? mysupercoolstartup.com or something like that. Right? mybilliondolarstartup.com, actually. So day one, this is good. Of course, you're going to maybe launch a first version, a private beta. You're going to start building your community. You're going to, start adding some users to that platform. And as you get more traffic, I would say the obvious choice, the gut reaction of everyone is going to say, oh, I need a bigger server, right? Because that's exactly how you've been trained and formatted and told to do things when you were in engineering school or at the university. You need a bigger server. Okay, fine. On AWS, it's very easy to have a bigger server. You stop the existing server, you select a bigger one, and you start it. It takes about a minute to do that. So you're going to scale up, right? Add a bigger server with a more powerful CPU, more RAM, etc., more I/O. Very natural way, right, to do things. And that's good. That's good. And we have a nice selection. You can go to crazy high instances, with 36 cores and hundreds of gigabytes of RAM, and quite a lot. Of course, this will end at some point. So if your app is successful, at some point, you will get more traffic than a single instance will be able to handle. So you will hit the wall. So it's okay in the beginning, but don't wait until you hit the wall to consider a different option. Okay. So you can still go up to maybe a few hundred, maybe a few thousand users with that solution. But on top of maybe performance issues, you have other issues. You have no failover capabilities. If that instance dies, if that server dies, your application goes down, and that's a bad thing. So no redundancy, and basically you've got all your eggs in one basket, right? The web app, the database, all your tools, all on one instance. So we need to fix that. So hopefully by the second day you realize that, but it could be day 64, right? It takes a little more time for some people to understand that. But okay, let's say you're super clever and by the second day you already realize this is not a highly available architecture. So first of all, you're going to split the web part from the database part, right? That's good practice, actually, in any platform, to separate the web tier from the database tier. So you're going to keep your web instance for the web app, and then you need to consider where your database is going to live, okay? And you have a number of options. So you could run your own database. So you could start another EC2 instance and install, let's say, MySQL or Postgres or whatever database you want to run on. And that's fine. I mean, you could install Oracle if you wanted to and bring your own license and manage that completely, okay? So that's the self-managed part. It's fine if you want to do that. You can also consider different options where you're going to use managed services where actually you don't have to start a virtual machine and install a database. You can actually access a database service that is running in AWS. So a very popular one is RDS, which stands for Relational Database Service, and you can run it with MySQL, Postgres, MariaDB, SQL Server, Oracle, and the newcomer Aurora, which is highly scalable, and I don't think I forgot any of those. So RDS is very popular. We have more than 100,000 customers using RDS, so it's it's an important service for our customers. And that's transactional databases, SQL based, etc. So if you want NoSQL, at this stage of your application, it's unlikely you really need NoSQL because you don't have such a large traffic. But okay, you could use DynamoDB, which is our managed NoSQL service. And if you want analytics, data warehouse systems, which again at this time, at day 2 in your startup, it's unlikely you need that. But maybe for later, you can use Redshift, which is a parallel, extremely efficient data warehouse service. So let's keep it simple. We're a small startup. We're building maybe a PHP application with a MySQL server. So we're going to stick with RDS and RDS with MySQL. So we're doing that, okay? And so we're growing slowly, right? We're picking up traffic. We have hundreds of users. We have our web instance, and we have a separate RDS instance, which is, again, a managed service. And this is nice because you don't have to worry about backups. You don't have to worry about all those things. This is part of the managed service. You can focus on building your application and growing your business. Still more traffic, building your community. And maybe you have a problem. Maybe your server went down and your users start to complain. So you really need to start fixing that availability issue. So basically, what we're going to do here is we're going to start a second web instance, second web server. We're going to put a load balancer in front of it because it needs to be completely transparent to your users that you have actually multiple web servers. And you're going to start those instances in different availability zones. So availability zones are part of the AWS infrastructure that are completely independent from one another. Okay, so should one availability zone go down, that's a really, really bad event, but okay, it could happen. Then all the infrastructure resources running in the different availability zone are still running. Okay, these are backed by multiple data centers, different data centers, which are apart from one another. It's if one AZ goes down, the other ones keep running. So that's why you need to have instances, web instances, and database instances in different availability zones. This is the best way for you to build high availability in your application, and it's really, really easy to do. Okay. So simple architecture, load balancing, a few web servers, and a couple of RDS instances, all of them running in different physical locations so that, if something bad happens, you're still up, okay? And actually, this is the foundation of many, many applications and many architecture. And by just growing that, you could go extremely far. It doesn't need to be more complicated than that. Okay, so let's fast forward. Your business is growing. Your mobile app is picking up. You're in the top 5 downloads of whatever app store you like best, and you're growing to thousands and thousands and maybe 100,000 users. And you can still rely on that same architecture I showed you. Okay, it doesn't need to get really complicated. The only thing that you would do, right, is maybe add more web servers and maybe add more database instances. Okay, so just scale out instead of scaling up. Okay, scaling out is the process of adding lots of small servers working in parallel, right? Versus scaling up, which is trying to get a bigger server and a bigger server and a bigger server until there is no bigger server. Okay, so this is the typical scale-out architecture, which is used by thousands and thousands of companies. And the only things that you need here, again, you need load balancing, you need EC2 instances for your web servers, you need RDS for your database, and you need multiple availability zones to guarantee the availability of your application, right? So, I mean, I'm a simple person, I like simple things, and because I understand them better, I guess, and it's easier to run, it's easier to manage, it's easier to scale. So, you could go extremely fancy, or you could go extremely simple, and again, trust me, this will scale very, very, very high. Okay. So, fine, but does it mean it cannot be improved? Of course not. Everything can be improved. So let's look at how to make this even more scalable and even more efficient. So first of all, there's a slight problem with that architecture. We're serving everything from the web servers, okay, including static content. So if you're serving images, JavaScript, CSS, videos, whatever, it's a shame to actually go to the web server, to the dynamic web application to serve that content. So the first thing we're going to do is to offload all the static content to CloudFront. So CloudFront is our CDN, our content delivery network. I'm sure you guys are familiar with that concept. So basically the idea is, instead of storing this content on your instances, you're going to store it in S3. S3 is the object store in AWS, where you put all your files and all, in this case, let's say all your images and videos. So it's stored off instance. And it's going to be served to your users, as you can see here, through CloudFront. And CloudFront is again our CDN. We have 53, I think, or 54. Someone is going to correct me afterwards, but 50 plus locations. We call them edge locations. So 50 plus points of presence all across the world where users can connect and actually get their content. So let's say you're hosting your platform in Ireland, which is one of our locations. Your web server and your database is going to run on our servers in Ireland. But your user, let's say you have a user in Marseille, and we happen to have a CloudFront point of presence in Marseille. All the static content is going to be served from Marseille. So all the heavy stuff, the videos, the pictures, etc. They're going to be downloaded locally from Marseille, so with much better performance. And the dynamic stuff will be served from Ireland. Okay, so I'm just explaining the CDN concept. If you didn't know that. Okay, so that's a nice improvement. We're offloading all that stuff to CloudFront, and potentially, now we're able to use smaller web instances, so less expensive too. The second thing we want to offload is all the session stuff, all the state stuff that you need to manage in a web application. So, all the user data and anything that you need to store during a user session. So again, you have to keep in mind that instances, they come and they go, right? You can start them, you can stop them, and you don't want to have too much local storage on those instances. So it's a good idea, again, to offload, and also for performance reason, to offload all that stuff, let's say, to DynamoDB, right? Store your session data, your cookie data, anything that you need to manage. You need to get that off the instance and put it in DynamoDB, which is a good place to do that. Okay, so that gives you or a cache system like Elasticache, which is like a managed memcached or managed Redis, if you know that. Okay, so that gives you performance improvement, and that gives you peace of mind that if your instance dies, you're not losing any data actually, because it's again stored off instance. Okay, so well, once we've done that, we've made our platform much more efficient and probably a little safer too. Actually, you can go even one step further because CloudFront is able to manage some of your dynamic content. So you could actually put CloudFront directly in front of your load balancer and cache in CloudFront some of the dynamic content as well. You know, always the same idea to offload as much traffic as you can from the web instances. Okay, anything that you can take care of even before the web servers is a good idea. Okay. Okay, so this is pretty cool, and this is a better platform. So okay, we took care of that part. Now, what's the next step actually? Let's say we still have more traffic, and we're getting tired of looking at instances, looking at databases, and managing that. So we need something to take care of it automatically, and this is called autoscaling. So the name is pretty obvious. So autoscaling is adding and potentially removing resources on demand based on some metrics. So you could say, you could monitor the CPU load, you could monitor memory usage, you could monitor network traffic, and say, okay, whenever CPU load on my web server exceeds 75%, okay, I need more instances. And if my CPU load goes below 20%, then I can remove some web servers. Okay, so that's autoscaling. It's very easy to deploy, and again, it's used by thousands and thousands of companies. And by using autoscaling with that same architecture, you can again scale to hundreds of thousands of users. So it's exactly the same architecture as before. Okay, the only difference is you can see on those white dotted line around the instances, they represent autoscaling groups. Where, okay, once again, you're going to define metrics, you're going to define policies saying when CPU load exceeds this number, please add 2 web servers, okay? And this just works automatically, so you don't need to worry about adapting your infrastructure to your traffic. It will go up when needed, and it will go lower when needed. So if you have less traffic at night, then you can reduce your infrastructure spend as well. Okay, so autoscaling is very cool. It works in the background, and you don't have to worry about it. Okay, and we could really stop there. I mean, there are huge companies running with this, right? I'm talking to a company called WOW. It's based in Iceland, and it's an airline company. You can check them out, wow.is. We're working on a case study with them, and that's pretty much what they have. And they're running the whole website and the whole booking system on this, EC2 RDS, and they scale, like crazy. So again, very good architecture, very easy to understand, very easy to scale. So I could go on for an hour refining this, EC2, RDS, load balancing, blah, 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 okay? But, the world is changing a little bit, so someday, you have to look at new technologies. And so that's the second part of my talk. And I want to start with this, which pretty much sums it up. So it's hard to understand for French people, so you have to read it a few times. So no server is easier to manage than no server. Right? Get that? So means, what it means is if you don't have any servers, then life is better, right? And that's a quote from Werner Vogels. He's the CTO of Amazon.com. He's been there for a long time. So you can listen to that guy and learn a lot of stuff. As a side note, it will be there at the AWS Summit in Paris on May 31st. I will talk about that later on. It will take care of the keynote, so it's always a good it's always a good time listening to him. So you should show up. So how could we have no servers, right? For 15, 20 minutes, I've been talking about EC2 servers, RDS instances. How could you have no servers? You saw the movie before. So yeah, we use the force. Well, I try to use it anyway. So how do you get rid of servers? So getting rid of servers means getting rid of EC2, getting rid of virtual machines forever, and getting rid of any service that still uses instances, like RDS, for example. So we're going to try and use only managed services which are fully distributed and which completely hide the fact, completely hide the underlying infrastructure, and you just use the service. And of course, I'm going to talk about AWS Lambda. Otherwise, I'm sure you would be frustrated, right? And so if you add those two together, you have serverless architecture, right? So that still makes no sense to most of you, I'm sure, but I'm going to show you this. So the best way to illustrate is that to show what some of the customers are doing, okay? So check this out. So this first company called, excuse me, Robotics, and you can read the case study on our website. So it's an analytics company with decent traffic. I mean, 100 billion events per month. That's not bad, right? And what did they build? Well, they get traffic from the internet. They send that to SQS. What is SQS? SQS is simple queue service, so it's a message queue, right? Again, I could talk about an hour on SQS, but keep in mind it's just a message queue. So you publish stuff and you subscribe to stuff, and that's it. So it's a publish-subscribe model, and you don't worry about servers. You just push and get messages to that queue. And then they have some service, some code that processes the data, and they push it again to Kinesis. So Kinesis is a different message queue. It's it fits a real-time system really well. So if you have streaming data that you need to manage in real time, you should look at Kinesis. Messages are ordered, they are persisted for a week. So you could push stuff in there and not read it, and it stays there for a week. That's really cool. You have durability of those messages. And then you have Lambda functions, which I will explain in a minute, that pull data from Kinesis and invoke some microservices. Okay? So, you could build a message queue yourself if you wanted to. You could install your favorite message queue middleware on EC2 instances, and you could try to do all this stuff yourself. But believe me, it's hard work. So using a managed service that scales automatically and is automatically highly available is going to make your life a little easier. So that's a simple example. Here's another one. Yeah. So it's a US retailer. It's called Nordstrom. If you've been to the US, of course you've seen those guys. Again, you can look at the case study. So what this guy do? They have a website, of course. They're selling their products on the website, and they wanted to build a recommendation engine. Okay, those boxes that try to get you to buy even more stuff that supposedly you're interested in. Okay, and they used to do that with servers and the old way, and it took about 20 minutes to actually deliver a recommendation. So imagine you go to their website, and you would have to stay for 20 minutes on their website to actually see a recommendation. Who stays for 20 minutes on an e-commerce website? No one. So they decided to build something themselves. And again, they're getting traffic from their mobile app and their website. They put that into Kinesis. It's processed by Lambda. It's pushed to DynamoDB, which is again our NoSQL database. It's processed by more Lambda function, and then it gets displayed. That data is available, and it can be displayed on their website. And you can actually try it. I mean, you go to Nordstrom, you click at a few products, and you will see recommendations immediately, and they're pretty relevant. So I find it really interesting that a company like this, who's not really a technology company, I mean, they're a retailer, they've built this themselves instead of going to a SaaS partner or a technology partner. They actually went and did it themselves. And they built it with AWS managed services. And by the way, they've decided to go all in on AWS, which means that they're closing all their data centers and moving everything to our platforms. And the last one I want to mention is it's an ad tech company called AdRoll. Do we have ad tech people in the room? No? No. All right. Probably having lunch. So AdRoll is it's a retargeting company in the US, pretty large scale, so 60 billion events every day. And again, from day one, they decided to use only managed services and Lambda massively to build and scale their platform. So all the details don't matter so much. You can look up at, you can check them out on the case study. But basically, again, they're using Kinesis, they're using Lambda, they're using DynamoDB. I mean, those three you're going to see everywhere, right? They're really the basis of serverless platforms. And again, you know, this is real-time bidding, real-time processing, large scale. You can see the growth of S3 usage and DynamoDB usage. It's fairly massive, and you know, they don't have to worry about a single server. Right? They don't have to, again, let me say that again. They don't have to worry about a single server. Okay, and what does it mean, worrying about a server, in case you don't know? It means monitoring it, installing it, well, buying it first, buying it, installing it, monitoring it, securing it, you know, fixing it, going to great length to keep it running all the time, 24/7. And if it's a physical server, then sometimes you have to go to the data center and change hard drives and memory inside the server, etc. So very funny on a Sunday night. I recommend it. So AdRoll, again, pretty interesting case. So let's look at a real example and a live demo. So what I'm going to show you here is a simple, it's a simple example, but it illustrates, hopefully, what I've been mentioning. So I've created an API, right? So it's a REST API called /prod/logger. So I'm just trying to log some events, right? It's a common use case in web applications, calling up an API to log some data. So it's going to go through the API gateway, which is a fully managed service. That API is going to call a Lambda function, which is going to write into DynamoDB. And then I have a trigger in DynamoDB, which is calling a second Lambda function, which is pushing that content to Firehose, Kinesis Firehose, which finally is pushing this to S3, and then it's ready for consumption by, you know, a Hadoop job or anything. Okay, so a few steps. And of course, the question that you will get asked just after I showed it to you is how many servers are involved and how many lines of code are involved. Okay, so let me show it first, and then we look at the details. Is that large enough, or? Can you read it? Yeah? Okay. So let me show you my fancy test program. Okay, this is what I'm doing. So I'm calling that API with curl 1,000 times, sending a silly JSON document, but that really doesn't matter. And I'm sending that to the API that I created. Okay? So let's do that. Okay, so I'm calling that API 1,000 times. Okay. What's happening? So, hopefully, within a few seconds or within a minute, I should see that stuff showing up in here. So that's the S3 console. So let me delete those old files. Oh, maybe they're here, yeah. Yeah. Okay, so I'm just calling an API, and this should go into that pipeline. I will show you the steps afterwards. But I wanted to show you the result first. Okay? And what I'm waiting for is those files, that data actually to be delivered as files here. Should take about a minute. There it goes, okay? All right, so that's the first example here. Should be able to open that. All right, so I get my events, right? So it's simple application, calling an API and going through some steps and getting that data logged into my S3 object store, right? Sounds simple. Okay. How would you do that in the normal world? I'm sure we have developers in the room, so how would you do that? Not using cloud services. With normal, I would say with classical infrastructure. Let's say you have a PHP or whatever. So you would log to what? You would use syslog or you would log locally and then push the logs to a central place. Okay, and that's fine for one server. And when you have 200 servers, how do you do it? Right? And when you have 1 million hits per second, how do you do it? It gets trickier, right? How do you get all that stuff under a minute from the web, let's say the web server, to a central location where you could have a Hadoop job or a Spark job doing analytics on it, right? 1 hit per second is always easy. One server, 1 hit per second is always easy. Okay, multiply that by 10 and by 10 and by 100, and then it's a lot of problems. Okay, so this is working, and I think I should get a file. Yeah, okay. I get a file every minute with my content. Okay, so how does that work? So how many servers? Any idea? Let me show you that slide once again. Okay, how many lines of code? Okay, so let me show you quickly the different steps. So API gateway. I suspect this is too small. Can you read it? Yeah? Yeah? Okay. So API gateway. So this is what I did, right? You could do it in a few clicks, or you could use the CLI, the command line interface. So it's a REST API, so I created a logger resource and I created a post method, right? I could have authentication, I could have lots of different things going on, but for now, this is just a simple test. So my data goes through the API gateway and then it gets to my Lambda function automatically, right? This is just configuration. Lines of code, 0. So here's my Lambda function. So Lambda is about deploying code, right? When you use EC2, you're going to deploy servers. When you're using Elastic Beanstalk, which is kind of similar thing to Heroku, you're going to deploy packages, deliverables. If you use, you could use containers, right? Well, here, the only thing you're deploying is code. You're deploying a function, okay? So this is my function. So it's Python. You could do Java, Python, or Node.js. And as you can see, it's extremely complex. So I have a print message. I'm adding a timestamp variable to my JSON document, and then I'm just storing that event into my DynamoDB table. So lines of code. So don't tell me this is 14 lines, okay? This is really, okay, line 9 is important, line 12 is important, and 13 and 14 could really be 1 line. So this is really 3 lines. Plus grand? Sure. Okay. We have some seats here if you want. I mean, come here. I don't bite. Okay, so 3-4 lines of Python code that everyone can write, because if I did it, then you can do it too. That's it. Okay, so 0 lines for the gateway, 4 lines, 5 lines for the Lambda function. This is enough to get the data coming from your web client and put it in DynamoDB. Okay, and actually you can see it here. Okay, that's my DynamoDB table. So if I'm scanning it, no, yeah, probably. All right. Okay, then I see my events here. Okay, so each line here is one curl call. Okay. How many servers for DynamoDB? 0. Manage service. So the only thing you have to do is create a table. Okay. Give some scaling information, how many read and writes per second are you going to do, and that's it. And then you can use, in this case, the Python SDK to write stuff to it. Did you worry about installing a database? No. Managing it, patching it, right? Anyone using Cassandra? No? Good. Oh, I'm on tape. Ha. Doesn't matter. Okay, so some people think it's a good idea to run Cassandra in EC2 clusters. Fair enough. I hope it works for them. I would think it's easier and less painful to use DynamoDB and not worry about EC2 instances at all. Okay. Sure. Yeah, security is really important. I can't go into all the details, but there is a lot of security configuration in the background. But it's not passwords. It's policies, roles, etc. It's all in a framework called IAM, which stands for Identity and Access Management, which is the way AWS manages all the security. And the default rule in AWS is very simple. Is nothing is allowed, right? So to allow an operation, you have to explicitly allow it. So by default, in this case, the Lambda function is not allowed to write to DynamoDB, so I have to create a policy allowing it to do that, attach it to the function, etc., etc. So yeah, it's all secure. Okay. All right. So DynamoDB, and then what's the next step? Then, okay, I have a trigger. Remember? So anytime something is written to DynamoDB, I have a trigger, which is similar to what you would see in other databases. And that trigger, what is it doing? It's calling another Lambda function. So how many lines of code to write the trigger? 0. So second Lambda function, still Python. So what does this one do? So this one is a little bit more complicated, because actually I'm asking DynamoDB to batch the events. Okay, so I could tell DynamoDB every time there's an update, please call the Lambda function. Here I'm waiting for 10 updates to call the function, right? It's a little more efficient. So this is why on line 13 and below I have to iterate on the records. And for each record, what am I doing? I'm sending that record into Firehose, which I will explain in a second. Okay, so anytime this trigger is called, I go through all the events and I push them to Firehose. How many lines of code here? Okay, 8 is important. Okay, 1, 2, okay. Can we agree on 4 lines? 4 or 5 lines? Yeah? Okay. The rest is just really noise. Okay, so let's look at Firehose. Whoops. So Firehose is just a pipe, right? It's a very scalable pipe where you just put data and you can write it to different places within AWS. And the one I'm interested in right here is S3. And so the only configuration I have to do here is to say in what bucket, okay, I'm going to store this in S3, so okay, JC mon public. The buffer size is how much data should go into Kinesis Firehose before it's actually flushed, so 1 megabyte. How many seconds should I wait before flushing, so 60 seconds. So that means if 1 megabyte of data is written, then Kinesis is going to flush the pipe, or it's going to flush the pipe every 60 seconds. Okay, in my case, I don't have a lot of data, so this is why we see 1 file every minute, because we have this flush every 60 seconds. Okay, I could ask for that data to be compressed automatically, and I could ask for that data to be encrypted automatically. Okay, again, try to imagine how you would do this, how you would build this in a scalable, reliable, highly available way with, let's say, off-the-shelf tools. It's not as easy as it seems. Okay, compression, encryption, key management, etc. Not so easy. Monitoring, what do we see here? Well, okay, I can see some stuff happening, right? So I pushed, all that data, and I can see it here. Okay, and then, well, that's it. We're at the end of the pipe. So if I'm refreshing this, I see more files, right? And I see 1 file every minute, more or less. Okay. How many servers for Firehose, by the way? 0. How many lines of code? 0. So, can we sum that up? So now you know the answer, right? So how many servers total? I have stickers. Come on. You win stickers even if you get a wrong answer. So come on, give me an answer. None, absolutely. Thank you. You can get many stickers. If I had a t-shirt, I would give you a t-shirt. But if you come to the summit, I will give you a t-shirt. Right. So, thank you. The answer is 0 servers, 0 instances, 0 virtual machines that are going to break at night or on the weekend and ruin a perfectly good barbecue or a nice evening at the movies or something, right? Believe me. How many lines of code? So I'm an honest guy, so actually I counted a little more, so it's 16, but it's really less than 10 lines of code. Okay. Again, you could do Python, you could do Java. Java would probably be 200 lines because it's Java, but that's why I'm using Python. All right, just trolling for a second. Now, I'm showing this thing at 1 hit per second. Now, imagine your business is growing like crazy, right? You're number 1 on the App Store, and you got featured on Capital or something like that. And all of a sudden, you have 1 million hits per second. You have this crazy peak. Do you have to change anything in here to handle 1 million hits per second? Well, not so much, huh? I mean, all of these are managed services, so provided that you have the right limits, we have some limits on the services to protect users from doing mistakes and spending too much money. But okay, let's say you have reasonable limits on these different services. All of them are managed by us, so we guarantee scalability, transparent scalability for those services. So if you need to have let's say 1,000 Lambda functions running in parallel to store the traffic into DynamoDB, then fine. Okay, it's all transparent. Okay, so another benefit of the serverless infrastructure is that it's transparent scalability. So you will never go down. You will, well, maybe one day, but it's hard to say never. But you should never go down, and you should never have any scalability problem. At least if there's one, it's probably our fault, not yours, right? So we'll fix it. Okay, so that's a cool architecture, you can go very, very high with this. And some people would say, yeah, but it's hard for me to build my application completely with this. And probably yes, you're right. So some pieces of your application could fit really well in there. Let's say if you have a mobile app and you want to build backend services, you want to build REST APIs for your mobile app. This is a dream way of doing it, if you ask me. Okay, so some projects can be done completely like this, and some projects can't. But pieces of the project certainly can, right? for stuff like logging or data, moving data from A to B in a scalable fashion. It's a good way to do it. So if you tried something like this, it's hard to put a limit on how high you could go. I'd say the limit is probably how much you're ready to spend with us. Okay, hopefully. And actually, 10 million. Why 10 million? Why not 100 million? And this is a really, really cool tweet from one of the founders at Supercell. So who's playing Boom Beach, Clash of Clans? Come on, raise your hand. Come on, there's 100 million of us, so we have to have a few in the room. If not you, maybe your kids, right? You're ashamed to admit it. I play Boom Beach. And so they passed, so that's March 7. So on March 7, for the first time ever, they had 100 million active users, active gamers on the same day. And so congratulations to them, and we're quite proud of that fact, because they're an important customer for AWS. So they manage 45 billion events every day, many terabytes, and they heavily rely on Kinesis, EMR, which is our managed Hadoop service, DynamoDB, which I showed you, and S3 and Glacier, which is another storage service. And I love that quote. We don't have to worry about the infrastructure. We worry about our users, our quality of service, our gamer experience, etc. And AWS takes care of the plumbing, right? So that's nice, and cheers to Supercell. How about that one? Who is using Airbnb? Right? Okay. Okay, so it's okay to admit that you're using Airbnb. Who's using Tinder? Yeah. All right, that guy is looking for a girlfriend. Okay, so Tinder is another pretty scalable customer of ours. So Airbnb, fantastic success, and there's this legend which is actually true, that do you know how many guys are in the Airbnb production team, their ops team? How large is it? Oh, you've seen that movie too, right? Yeah, you win a sticker. 5 people. So okay, so by now it's maybe 6, right? But okay, it's not 50. Okay, so it's 5 guys running the whole infrastructure of Airbnb, and I'm quite sure these guys love their weekends and their holiday, and I'm sure they get great deals on some of the rentals. So I think they'd rather go on Airbnb and rent great places and have a good time instead of spending their weekends fixing stuff on the infrastructure. So if it's 5 guys and it seems to be running well for them, what does that tell you about the AWS infrastructure? That's almost the end of my talk. So now it's really your turn. And going back to the day one thing, I'm sure we have people here who are working in startups or thinking about creating their own startup. But please go and do it, right? And the nice people at the family are going to help you. That's what they do. So go and do it, and please try all those services. If you haven't done so yet, create an account on AWS, start using the services. It's going to cost approximately 0 for a long time, because for the 12 first month, a lot of the services have a free level of usage. So unless you start really heavily using the service, you really pay nothing. So it's really, really not expensive to, there's no subscription, there's no monthly whatever. You pay but only for usage, and if you shut everything down, you stop paying, right? So don't believe me, go and play with those services, and let's see what you can build, okay? If you're interested in Lambda, and I think you should, if you're a developer here, you should really, really look at Lambda. And maybe you'll decide you don't like it, but I don't think you can afford not to look at it. One of my colleagues is writing a book on Lambda. It's not published yet, but you can get an early release on the Manning website. So you can buy the PDF file and you get all the updates. I think he has already 6 or 7 chapters written. So is really an expert on that topic. So if you're going to buy one Lambda book, that's the one. Look no further. some events. No, actually, classic. I forgot the next one. So we're going to be at Devox. Is that next week? Yeah, next week. Anyone coming to Devox? No? Come on. So we'll be there, right? In case you change your mind. We'll be at .scale too. And more importantly, as I mentioned, we have the AWS Summit coming up on May 31st. So that's the annual technical conference in France. It's free. It's in Paris at Carrousel du Louvre. 1 day of tech sessions, business sessions. If you're a beginner, please show up. About half the people that actually attend the summit are beginners, newcomers to AWS, so you won't be alone. If you already know AWS, please show up. We have a track for developers with deep dives and pretty cool serverless and IoT sessions. So it's going to be interesting for you guys, even if you already know AWS. If you're looking for training on AWS to speed up your adoption, you should definitely consider what we call the Awesome Day. It's a 1-day event, also in Paris. It's also free. And there's one every quarter, so next one is in June. You can already join that. And it's 1 day of training with one of our technical trainers on all the main AWS services. So he's gonna talk about EC2 and S3 and RDS and load balancing and a whole lot more. So if you want 1 day and really go home with a good understanding of AWS, please don't miss the Awesome Day. Last but not least, we have user groups. We have one in Paris, which has been running for a while, and I'm starting some more all across France. So one in Lille, Rennes, Nantes, Bordeaux, Lyon, Montpellier. Do we have people outside Paris here? No, I didn't think so. Okay. With more coming, more cities. So you could still obviously join the Paris group. Do we have some user group members here? No? All right, so you're all invited. You can find all those groups on meetup.com. If you look for Paris AWS or Montpellier AWS, they're pretty easy to find. And please join us. We have some cool sessions about every month. We have a group, community we're starting to build on Facebook, so that's nice too. And of course, you can follow the official AWS Twitter account. Okay. Well, thank you. That's the end of my talk. You have my email address. You have my Twitter account if you want to get in touch and yell at me because Lambda doesn't work the way you like it. That's fine. I can read that. So thank you so much for listening. Feel free to steal all those stickers here. Not this precious piece of art, but everything else can go. I have business cards here if you want to. And if you have any questions, I'm more than happy to answer them. Thank you so much for listening, and thank you to the family for inviting me. It's always a pleasure to be here. Thank you so much.
Okay, thank you so much, Julien, for the talk. Thanks. I've got one question about scaling out with EC2 instances. What is the metric that we have to monitor when we are running a web server or a DB server? Okay. And we need to.
It's an excellent question, and it's a difficult one. I would say, the easy answer is it's going to be application dependent. Right? You could have, let's say, APIs like like the one I showed you, for example. If you're running web services which are just logging stuff to, syslog or something else, it's going to be it's not going to be very CPU intensive, but it's going to be, let's say, network intensive. You could have other applications that are disk intensive, etc., etc. So I would say, in general, for a general purpose web application, CPU load is still going to be the number one thing. If you're running, let's say, a B2C website, e-commerce website, etc., your traffic is going to come from users. You're going to perform some business tasks, whatever it is. and CPU is usually where you need to look. That's just one metric. So I would say, if you're using, unless you're convinced that whatever you do is not CPU intensive, it's IO intensive or disk intensive, start with the CPU, and you can go from there. I would also advise you to start with one metric. People don't over-engineer. That's my point. Don't try to say, okay, if I have this combination of CPU load and disk load and network load and number of processes and blah blah blah. Keep it simple, right? So you want CPU usage to be, if it's durable, if it stays at above 50% for a while, you want to scale. Right. Last thing I can say, I could talk about this for hours, but the last thing you want to consider is, do not wait for CPU to be at 90% to scale, right? Because if you're at 90%, you already have peaks, you already have latency, and some of your users are already getting a crappy experience. So scale early, right? It may seem like a waste of money, but losing users because your website is slow is the worst problem that you can have, and usually they don't come back. If you gave them a crappy experience, they don't come back. Okay, so 50% is a good way of saying, okay, if I'm staying there, maybe I want to scale, right? But again, the last thing I want to say is you need external monitoring too. So I don't know if I'm able to recommend some services, but stuff like Catchpoint or a New Relic or your own Graphite server running somewhere else. I don't know, something like that. But you need something external to your platform, external to the cloud, to get a really good sense of what users are really seeing. Because monitoring the CPU load on your EC2 instances, that's going to tell you one thing. But what you want to know is, I've got this 3-page or 5-page scenario on my website, and how long does it really take to fulfill for a normal user? Okay, so you want to have some kind of robot going through that scenario and measuring the latency. Okay, and this is the absolute truth, right? So if those numbers suck, well, then you need to improve your scaling and you need to improve your AWS monitoring. But so it's a combination of both. Sure.
Because the thing is, today our architecture is using the scale-out architecture, but I don't know what to answer when someone is telling me, yeah, but look, your instance is on micro free tier, and is laughing, and I'm just like, yeah, but if I have got so many micro, it's
so don't listen to anyone, right? Build your own idea of what your platform should look like. Actually, I always tell everyone, start with the smallest instances possible. Okay, because they're cheap, and because and you're right, they're in the free tier, which is good, and you won't scale out, right? So if your application is small enough to run correctly on T2 Micro, there is no reason to change, right? And you could even try T2 Nano now, which is even smaller. Okay, so let's say for a web application, the thing to consider is for one single request, how much time does it take for an average loaded T2 Micro instance to process it, right? If it takes, let's say, 1.5 seconds, and you think it's not acceptable, then you need, 1, to optimize your code, 2, but only after you optimize your code, you need to have a bigger instance. Okay, so you need to look at how much time does it take to process one single request and what's acceptable, and you need to look at the total throughput. How many requests can one single server process? Okay, so if you end up being in a place where it takes 5 seconds for a single request, and you can only you can have maybe 2 requests in parallel on your micro instance, then okay, you have a problem, right? So you need to look at unit testing and, I would say, throughput, right? But if you can run on T2 Micro, good. Keep running on T2 Micro. Do not go any higher.
Hello, I got a question. Can you explain the lambda? I didn't get what
Okay.
is it.
So basically, lambda is I don't have a real name for it, so let's call it function as a service or code as a service. Basically, the only thing that you're deploying is one function. So take what we call a pure function because it is stateless. As you can see, once it's invoked, it terminates, and that's it. So if you need to keep any state, it needs to be kept in a database or in DynamoDB or in something like that. So the idea here is really to break your application into a series of tiny processing steps that can run in parallel. Okay, so instead of having a large monolithic application, which becomes harder and harder to scale as time goes by, right? Like I've got my big web app running in Topcat, and there's 10% of the code that really takes 90% of the time, which is really typical, right? Then how do you scale that? You can add more instances, but that doesn't really solve the problem because you want to scale that small part. So if you have broken that into many services, or let's say microservices, right? Lambda is really great for microservices. Then you could say, okay, maybe this Lambda function is really the hot spot in my application, but the Lambda framework is going to scale it as much as I need. So if I need 1,000 parallel invocation of that function, then fine, Lambda will do it, okay? So it's a different way of building applications.
Okay, thanks. I got another question.
Go ahead.
I can. If I want to start to create a platform, an entire platform, should I start on AWS or can I start on my own machine to use Redshift, DynamoDB, or it doesn't make sense at all?
So I think you should start on AWS one way or the other, of course, because it's, you can, again, ask that guy how much he's spending, right? I mean, with micro instances, probably not so much. So it's cheap. And it all depends on what your application looks like. I'm not saying 100% can be done with Lambda, right? I'm saying maybe some pieces make sense. Maybe you can have a PHP application or a Java application that runs, and because you have some complex business logic, and you feel more comfortable with writing code that way. But keep in mind that for parts of the platform that are really, small processing steps, potentially requiring a lot of parallel execution, right? If you identify those, then try to build them as Lambda functions with APIs, etc. So it's really, in the way of, the microservice movement and really breaking the monolithic application into tiny pieces that are easier to write, easier to debug, and easier to scale independently from each other. Okay, but try EC2, try RDS. We have lots of tutorials. Try Lambda. I mean, again, don't believe me blindly, right? Never do that.
We take one question there.
Hi. Life is not that easy that everything is parallel. So if we are in a case, by example, where you have, let's say, 3 lambda, and the third lambda should not start before the 2 other are finished. So instead of having something like, one lambda finish and call the other one, it cannot really call the other one, but you don't want that lambda to wait for the first one. How would you do that?
Well, I mean, a lambda function can call a lambda function. So how you orchestrate your application is entirely up to you. So, I mean, you decide how those things work with each other. I mean, if you have a dependency between lambda A and lambda B, then maybe lambda A can call lambda B just before it terminates, or maybe lambda A will push a message to Kinesis, let's say, and lambda B is waiting for that message. I mean, how you orchestrate that is entirely up to you. We provide the building blocks to do it. There is no synchronization framework or whatever, because I don't think you can build that in a very generic way. So it's all about building those, as I was explaining, building small services that either run totally independently from each other, and then there's nothing to worry about, or they have dependencies between each other, and you decide how you want to link those, right? It could be lambda calling lambda, it could be lambda pushing a message to lambda, it could be, there are a million ways to do that, but
Thank you.
Keep it simple. Keep it simple. Keep it
We,
simple.
we take one last question.
What is the difference between a Lambda and a microservice? Is this the same thing?
So a microservice is a concept. Okay, it's a movement, it's a philosophy, it's a religion sometimes. So again, the microservice philosophy is breaking the monolith into smaller pieces that can be written, tested, debugged, deployed, scaled in parallel, potentially by different teams. Okay, so that's just a philosophy of architecturing applications. Lambda, I think, is a great way of building microservices, because it's an implementation block that I would recommend that you use for microservices, especially with the API gateway in front of it, because when you have microservices, it's quite likely you will have APIs that are open and accessible to the outside world.
I have a question. It's about in the day one, your architecture, there is Route 53.
Oh yeah.
And what
yeah,
is...
so thank you, forgot to explain that. So Route 53 is our DNS management system. So you can host your own domains within AWS. So as always, it's a managed service, it's highly available, etc. It's scalable, etc. So basically you can declare your own domain names and your CNAMEs and your zones into Route 53. And you can assign them to your instances or your services within AWS. So it's just a registrar and a DNS, a scalable and redundant DNS architecture. Yeah, you could use domains that are hosted in externally, of course. But if you'd like, you can also host the domains within Route 53. And Route 53 also gives you some routing and load balancing policies, like round robin or latency-based routing, which I think is pretty cool. Let me explain that in a second. So if you have infrastructure, let's say in the US, in AWS, and you have infrastructure in Europe, in AWS as well, and Route 53 is a global service. So it's going to manage users that could be calling from the US, and it's going to route them to the US infrastructure. And then if they move to Europe, they're going to be routed to Europe. So it's not just domain names and CNAMEs. It has some routing and failover policies, which are really cool. So you need to look at that as well. Well, I'm still around for a little while, so we need to. They're kicking me out. So please grab all those stickers, and if you have more questions, we can continue. Thanks again.
Que la famille.